There has been a lot of chatter recently regarding a supposed leak of the Claude Code architecture. Many people assumed they had stumbled upon a secret file containing the proprietary blueprints for production AI agents. However, the reality is far more nuanced and perhaps more revealing. What was presented as a leak turned out to be a collection of reverse-engineered manifest files that expose the underlying structure of how these agents operate. This distinction is crucial because it shifts the conversation from a security breach to a forensic audit of the design itself. We are looking at the actual mechanisms that drive these systems, and that reveals specific architectural gaps that could lead to catastrophic failures in high-scale environments. To understand the gravity of this, we have to look at how these agents are instructed. The leaked materials show a focus on what researchers call Agentic Coding Manifests. These are essentially structured text files, often named Claude.md, that tell the system what it is allowed to do. Think of this like a job description for a highly specialized employee. It outlines the tools they can use, the files they can access, and the logic they should follow. The problem arises from the fact that every single line in these skill files is interpreted as an active instruction. This means the system does not distinguish well between a command and a piece of data. Here is the thing that makes this architecture fragile. When a malicious actor introduces a prompt injection, they can exploit this interpretation. A prompt injection is a technique where someone feeds the system input that looks like data but acts like a command. In the context of these skill files, researchers have found that trivial prompt injections can bypass guardrails. This allows a bad actor to exfiltrate data through seemingly benign markdown files. It is as if you gave a contractor a blueprint for a house, and they found a way to read your personal diary hidden inside the construction notes because the system was designed to read every word it saw as an order. This vulnerability underscores a fundamental insecurity in current production agent designs. The system assumes that the manifest file is a trusted source of truth, but it lacks the granularity to separate instructions from content. In a high-scale environment where thousands of these agents are running simultaneously, a single vulnerability can cascade into a major breach. The architectural gap lies in the lack of a secure sandbox or a strict separation of concerns between the manifest definition and the execution environment. Now consider the second major issue revealed by the analysis, which is the reproducibility of the code these agents generate. While the agents are becoming more autonomous, there is a significant knowledge gap regarding the code they produce. Independent research confirms that AI-generated code currently suffers from dependency gaps. This means the agent might write a function that calls a library or a module that does not exist in the environment. It is like a chef writing a recipe that calls for an ingredient that is not in the pantry without realizing it. This makes it difficult to deploy the code without manual intervention. The agent can write the logic, but it cannot guarantee the environment is set up to run it. In a small test, this might just mean a failed build. In a production environment, this could mean a service goes down, or worse, it forces a human engineer to step in and fix a problem that the system should have handled autonomously. This dependency gap is a critical hurdle for the transition to full autonomy. We are moving away from what is often called vibe coding, where the output is based on general intuition, towards structured autonomy, where the output must be reliable and executable. The tension between the need for precise, standardized context and the persistent risks of prompt injection attacks remains unresolved. We are seeing a shift toward robust, manifest-driven agents, but the security and reliability hurdles continue to impede full production readiness. The field is transitioning, but it is not ready for prime time. The blueprint we are examining shows a system that is powerful but brittle. It relies on shallow, hierarchical structures focusing on operational commands and architecture. This signaling is clear, but the foundation is shaky. We must also consider the implications for the developers who are building these systems. If the skill files are the primary interface, then the security of those files becomes the security of the entire system. Every line of code in the manifest is a potential attack surface. This requires a new approach to security, one that treats the agent instructions with the same rigor as the code they execute. We cannot rely on the assumption that the manifest is safe just because it is internal. Furthermore, the lack of standardization across different platforms complicates the landscape. While studies have established patterns for these agentic coding manifests, there is no universal standard. This means that a vulnerability in one system might not exist in another, but it also means that security tools cannot be easily generalized. Each platform requires its own forensic analysis and its own set of guardrails. This fragmentation slows down the adoption of these technologies in critical industries where reliability is paramount. The path forward requires a shift in how we think about agent security. It is not enough to build better prompts or stronger firewalls. We need to rethink the architecture itself. The goal is to create a system where the agent can act autonomously without compromising the integrity of the host environment. This involves better isolation, clearer boundaries between instructions and data, and more robust dependency management. Until these issues are addressed, the promise of autonomous software engineering will remain just out of reach. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.